In this video, we'll explore atomic number, average atomic mass, mass number, isotopes, percent abundance, and how to determine the number of protons and neutrons in an atom. This lesson emphasizes conceptual understanding and the relationships between these topics rather than just rote memorization. Let's get started. So on this slide, you see a picture of elemental chlorine right here as it appears on the periodic table, along with an isotope of chlorine, chlorine 37, right here. Different values are shown for each, and we are going to discuss in more detail what those values represent. Specifically, we will explain the atomic number, the average atomic mass, or sometimes called the atomic weight, and the mass number. Let's begin with the atomic number, which is often written as the letter Z. The atomic number is the number of protons in the nucleus of an atom. It serves as a unique identifier of each element, almost like an ID card. On the periodic table, the atomic number is the smaller of the two numbers listed for each element. For chlorine, the atomic number is 17. This means that every chlorine atom, no matter which isotope it is, contains 17 protons. For example, both elemental chlorine on the periodic table and the isotope chlorine 37 have an atomic number of 17. All chlorine atoms, including all of its isotopes, share the same atomic number. Next, we will explain the average atomic mass, which is sometimes called the atomic weight. The average atomic mass is the weighted average of the actual isotopic masses of all the naturally occurring isotopes of an element. The equation for the average atomic mass is equal to the sum of the isotope mass times the relative abundance. It is measured in atomic mass units or AMUs. On the periodic table, this number is typically the larger of the two numbers shown for each element, and it is usually expressed as a decimal value. For example, the average atomic mass of elemental chlorine, as shown on the periodic table, is about 35.5 AMU. Let's now describe the mass number. The mass number is the sum of the protons and neutrons in the nucleus of an atom. The equation for the mass number is equal to the number of protons plus the number of neutrons, or the mass number is equal to the atomic number, which is equal to the number of protons plus the number of neutrons. The mass number is defined for a specific isotope, and it is written in isotope notation as shown here for chlorine 37. The mass number varies between different isotopes of the same element. Unlike the average atomic mass, the mass number is always a whole number. For example, in chlorine 37, the mass number is 37, while the atomic number is 17. On this slide, note the mass for a proton, a neutron, and an electron. Protons and neutrons have roughly the same mass, while an electron weighs about 2,000 times less than the mass of a proton and a neutron. Now, you do not need to memorize these values for the MCAT. They are shown here just to help you get a sense of how the masses of atomic particles compare to each other. Here, we are going to explain isotopes in more detail. The standard definition of an isotope is an atom of the same element that has the same number of protons but a different number of neutrons. Because isotopes have the same number of protons, they belong to the same element and share the same atomic number. However, they differ in their mass number and in the number of neutrons. The chemical reactivity of isotopes is essentially the same because they are composed of the same element and they have the same number of electrons, especially the same arrangement of valence electrons. On the other hand, isotopes often have different physical properties because the number of neutrons in their nuclei is different. Examples of physical properties that can vary include density, nuclear stability, and radioactivity, all of which depend on the number of neutrons and the nuclear structure. Examples of isotopes include chlorine 35 and chlorine 37, which are the two isotopes of the element chlorine. Now, in this slide, we will explain how to calculate the average atomic mass, which is sometimes called the atomic weight. The average atomic mass of each element is always provided on the periodic table. However, the atomic mass of a specific isotope is not shown on the periodic table. Instead, it will be given to you in a question stem or a passage. The formula for the average atomic mass is average atomic mass equals the sum of the isotopic mass multiplied by the relative abundance. The relative or percent abundance is the percentage of atoms of a specific isotope of an element compared to the total number of atoms of all isotopes of that element found in nature. Here are the steps you can use to calculate the average atomic mass. Step number one requires that you write down each isotope's mass in AMU, or atomic mass units. The second step requires that you write down each isotope's natural abundance. If the abundance is given as a percentage, convert it to a decimal by dividing your percentage value by number 100 or by moving the decimal two places to the left. Then multiply each isotope's mass by its decimal abundance. Finally, in the last step, we need to add the results together. The sum of the values is the average atomic mass. This concludes our video lesson. If you'd like to test your understanding of these concepts, check out the next video for guided practice problems. If you want to see how the MCAT may test you on these concepts, watch the video that walks through a complete MCAT-style passage. You can click on the video icons shown here or find the links in the description below. If you prefer the full version of this lesson, which includes the complete concept review, practice problems, and an MCAT style passage walkthrough in one video, you can access it by clicking the video shown here or by using the link in the description. Keep practicing and stay disciplined. You're making a lot of progress. Thank you for watching, and I'll see you in the next one.